Hello everyone, I am Dr. Naresh Kumar, Assistant Professor in the Department of Electrical and Electronics Engineering, Institute of Aeronautical Engineering, Hyderabad. Today, we are going to have a discussion on classification of DC generators. So, depending upon the excitation, field winding excitation, there are two types of DC generator. So, first one is separately excited DC generator and self-excited DC generator. Based on the field winding and armature connection or method of excitation, field winding excitation, classified as two types, separately excited and self-excited DC generators. Next, in self-excited DC generator, again three types of DC generator: shunt wound generator, shunt generators, series generators and compound generators. In the compound wound generator, again two types, long shunt and shunt type. So in the in the separately excited, there is no connection between armature winding and field windings. Field winding is separately excited with other battery. And in the self-excited, so here self-excited generated, the generated supply is given to the field winding. That supply is given to the field winding. That such type of excitation DC generators are called self-excited DC generator. If field winding and armature winding, depending upon the connection, so if the field winding and armature windings are connected in series, that is series wound generator. If field winding and armature winding is connected in parallel, that is shunt generator. If field winding and armature, two field windings and one armature winding, that type of generator is known as compound generator. In that, one field winding is connected in series with generator and other field winding is connected in parallel with generator. So such type of compound generators are called long shunt and short shunt generator. Now first I will explain separately excited DC generator. In the separately excited DC generator, so here field winding and armature winding are connected in there is no connection. Here first, so here AA indicates the armature winding and here FF and FF indicates the field winding. This one, FF indicates the field winding. Now here there is no connection between these two, armature winding and field winding. This field winding is excited with a separate battery. That battery voltage is V. And if you give this battery to the battery supply voltage is given to this field winding, current flows in the field winding, that current is IF. And here this field winding resistance is RF. And according to the Faraday's law of electromagnetic induction, here if you give this field winding, if you give supply to this field winding, current flows in this field winding. This field winding acts as a magnet. It is a stationary magnet. So now this current carrying conductor acts as a magnet. This magnet cuts this armature conductor and induced EMF will be developed in the armature conductor. And this is induced EMF EG here. Now here, if there is no load, no current flows in the circuit. And if you connect any load, if you connect one load and current flows in this circuit, that current is IL and this V is load voltage, terminal voltage, and here IA is the armature current. Now here RA is the, now if you represent this, EG is the generated EMF, this one, and V is the terminal voltage, this one, and VS is the battery voltage, and IL is the load voltage, and next IA is the armature current, this one, and RA is the armature resistance, and IF is a field current, and RF is the field resistance. Now related to this separately excited DC generator formulas, so first one, armature current formula and field winding current formula. Now here armature current formula means here IA and IL, IA equals to IL, because armature winding and this load are connected in series. In case of series connection, same current flows to the each element. Same current flows to the each element means IA and IL is same. because of series connection of load and armature. IA equals to IL, IA equals to IL, same current flows through each element in case of series connection. Now coming to the field winding current, that equals, here supply voltage is V, this is RF. Now here this voltage divided by this resistance is known as this current. Now here this voltage is battery voltage is Vs, and this field winding resistance is RF, and this current is IF. So Vs by RF is known as field current. Now induced EMF formula. Induced EMF formula equals, if you apply KVL in this loop, if you apply KVL in this loop, this is IL or some current I, so same current direction is same. So here EG equals to, if you apply KVL, this is IL equals to this load current equals to this load resistance. If suppose this load resistance is RL, this is load resistance, this is load resistance, and here this load resistance equals to RL. Now this current IL equals to V by terminal voltage divided by this resistance is known as this load current. Now here EG equals to V plus IARA. This is the formula. Now here if you apply KVL in this loop, algebraic sum of total voltages in a loop equals to 0. So minus EG plus V plus IARA equals to 0. Now that equals to, so algebraic sum of total voltages in a loop equals to 0. Now here EG equals to minus EG plus V IARA, armature resistive drop, plus this terminal voltage is known as the, so if you apply KVL, algebraic sum of total voltages in a loop equals to 0. Now EG equals to V plus IARA. Now here power generated equals to power generated power and delivered power. Generated power is different and load power is different. Here generated power means power is generated at generated armature terminals, and that armature power is transferred to the load, that power delivered to the load. So that are two formulas. Here this current is IA and this induced EMF is EG. This is generated power. And here that power is transferred to the load means this power transferred formula is the PL equals to IL into V, IL into E. This is the load power and this is the generated power delivered to the load. So these are the formulas related to separately excited DC generator. Next, self-excited DC generator. So in that shunt wound DC generator, in the shunt wound DC generator, armature winding and field winding are connected in parallel. If they are connected in series means that is series wound generator. Armature winding and field winding are connected in series in the parallel. Now here if you armature winding and field winding is connected in parallel, because of residual magnetism there may be a flux, that there may be a small induced EMF. So that induced EMF gives this field winding. Now here this field winding it acts as a electromagnet. It cuts the armature conductor and induced EMF will be developed in the armature conductor. And if you give this to the load and current flows in the circuit, and this current is IA and this current is IL, this current is field winding current. This is also known as ISH. Now here this resistance, field winding resistance is RSH and field winding current is the ISH. Because these two are connected in parallel, so that is shunt current and shunt resistance. It can be, we can call it as RF. Now here the representation. So EG is induced EMF and V is the terminal voltage and IL is the load current and IA is the armature current and RA is the armature resistance and ISH is the shunt current or field current and RSH is the shunt resistance or field resistance. Now related to this formula, just if you know the KVL, KCL and series connection and parallel connection properties, then we can easily give the armature current and field current formulas and induced EMF formulas. So first armature current formula, if you apply KCL here, So algebraic sum of entering currents equals to sum of leaving currents at a node equals to sum of entering currents equals sum of leaving currents. So here what are the entering currents and what are the leaving currents? Here entering currents is IA and leaving currents are IF and IL. IF means ISH. So here sum of entering currents equals sum of entering currents equals to sum of leaving currents. Entering currents and leaving currents. Here entering current is IA, only one current that is armature current, and two currents are leaving at this node ISH and IL. So ISH plus IL equals to IA. This is the first formula for armature current. Next, this shunt current equals to formula. What is the formula here? This voltage, what is the voltage in case of parallel case? Here field winding and armature winding and load all are connected in parallel. So in case of parallel connection, same voltage developed across the each element. Here same voltage developed across the each element means here this terminal voltage equals to this field winding voltage. So now here from here this voltage, if we know this voltage and this resistance, then we can calculate the shunt resistance. Here this ISH equals to this terminal voltage divided by RSH. Second formula is derived. Next, if you apply KVL in this loop. So now here what about IL here? So this IL already, this is the RL, load resistance. Now V by RL is known as the IL. This is third term, load current. Now here ISH and IL. If you know the ISH and IL, then we can calculate the armature current easily. So now here EG equals to V plus IARE. If you apply KVL, this is the second loop. If you apply KVL in the second loop, EG into IA, EG equals to minus EG plus IARA plus V equals to 0. Algebraic sum of total voltages in a loop equals to 0 according to the KVL, Kirchhoff voltage law. Sigma V equals to 0. So minus EG, so minus 2 plus and IARA plus V equals to 0. Now here if you simplify this one, what will be the equation? EG equals to V plus IARA. This is most important. So similarly in the separately excited DC generator, power generated and power delivered to the load formulas, same formulas here. So power generated at armature terminal and power is delivered to the load. So here power generated power and power delivered to the load means PG equals to power generated equals to IA into this IA armature current into induced EMF, that is power generated, and power delivered to this load current into the terminal voltage is known as the power delivered to the load. So this is regarding shunt wound generator. Now next generator is the series generator. In case of series generator, so armature winding and field winding are connected in series. So armature winding and field winding are connected in series. In case of parallel case, so armature winding and field winding connected in parallel. Now here AA indicates the armature winding and FF indicates the field winding. So here field winding current is I series or IF, and this resistance is field winding resistance is R series or RF. In case of shunt generator, RSH we represented, and here this EG is the induced EMF and this armature resistance is RA and armature current is IA, and if you connect the load, then current flows in the circuit, that current is IL and that voltage is V. Now here the representation here, EG is induced EMF and V is the terminal voltage and IL is the load current, and armature current is IA and armature resistance is RA, and I series is the armature series current, that means field current, and I series is the field resistance, that means series resistance. If it is connected in series means that we represented with R series. Now here this field winding acts as the electromagnet. It is a stationary. This stationary magnetic field cuts this armature conductor and induced EMF will be developed in the armature, and induced EMF will be developed in the armature conductor if there is no load and no current flows in this circuit, that IL and IA equals to 0. But here if you connect the load, then current flows in the circuit, then current flows, that current is IA and IL. Now if you see the formulas for series current, series field current, and IA armature current and induced EMF formulas. These are important for all the generators. So first here IA equals IL equals to I series. This is most important because here same series case same current flows to the each element. Here armature, this armature and field winding and this load are connected in series. So in case of series connection, same current flows through the each element, all as already we discussed in the previous slide. Now here IA equals to this armature current equals to field current equals to load current. Armature, field and load are connected in series. IA equals to I series equals to IL. That means this is IF. Now here what about the induced EMF formula? Induced EMF formula, if you apply KVL in this loop. Now here, so some algebraic sum of total voltages in a loop equals to 0 and minus EG plus IARA plus I series R series plus V equals to 0. All voltages, this voltage plus this voltage plus this voltage and armature resistive drop must be 0. Now here, so minus EG plus V plus IARA plus I series R series. Now this only. Now this EG is RHS EG equals to V plus IARA plus I series R series. We can call this IF into RF. Now these are the two formulas related to this series field winding generator. Now next case. So now here in this case, IA and I series both are same. So IA and I series are same. So now here you can take common. So what will be the equation? So IA is the common term. So here EG equals to V plus IA RA plus I series. So this is the final equation for series. We can use this one is also, but here I series and IA is same. So same final equation. So the equation will be EG equals to V plus IA RA plus I series. Next, power generated and power delivered to the load. Same formulas, PG equals to IA into EG and power developed to the load. This one VL into IL. This one and this one. Next, long shunt generator. Long shunt generator means here compound generators are classified into two types, short shunt and long shunt. In the long shunt generator, so in the compound generator we will use two field windings and one armature winding. So only the difference is the connection only for long shunt and short shunt. Here one field winding is connected in here, this ZZ is one field winding and this FF is one field winding. So ZZ field winding is connected in series with the armature winding and this FF is connected in parallel with armature winding, entire connection, and this one is connected to the load. This load is load voltage is terminal voltage is V and load current is IL, and this series field current is I series and this resistance is R series and this shunt field resistance is RSH and shunt current is ISH and this armature resistance is RA and induced EMF in the long shunt generator is the RSH. Now EG. Now here, now the formulas related to this. Now here we need the I series, ISH and load current and IA formulas. What are the formulas? If you know the KVL and KCL, then we can easily find out the equations for ISH, I series, IA, EG formulas. First, if you apply KCL at this node, so what are the entering currents and what are the leaving currents? And here, so here EG is induced EMF and terminal voltage is V and load current is IL and armature current is IA and armature resistance is RA. Next, I series is this one, a series current, and R series is this one, and I shunt resistance and shunt current and shunt resistance. Now here, if you apply KCL at this node, so what are the entering currents? I series equals to sum of entering currents at a node equals to sum of leaving currents at that particular node. Now here entering current is I series and leaving currents are IL and ISH here. Now here ISH plus IL equals to I series according to the KCL. If you apply KCL at this node. Now here what are the according to the series connection first property, same current flows to the each element. IA equals to I series. We can write this IA equals to I series. Now here I series in place of I series, I can write this IA equals to ISH plus IL. So this also we can write this, and ISH equals to same voltage developed across in case of series connection, same current flows to the each element. In case of parallel connection, same voltage developed across the each element. So V supply voltage, this voltage equals to this terminal, this feed winding voltage. That voltage divided by that resistance is known as the shunt resistance, this one. Now if you apply KVL, so now load current equals to this one, this current equals to, this is the RL, load resistance, the load terminal voltage divided by load resistance is known as this voltage divided by this resistance is known as the this load current. Now here EG equals to V plus IARA plus I series R series, same formula. So if you apply KCL at this node, algebraic sum of total voltages in yellow loop equals to 0 minus EG plus V plus IARA plus I series R series equals to 0. Now the simplified equation EG equals to V plus IARA plus I series R series. So this is the final equation. Now here IA equals to I series. So this one, these two are same. So now here over here IA is the common term and RA plus I series. So EG equals to V plus IARA plus R series. This is the final equation. Now what are the power delivered and power generated? Power delivered to the load and generated power formula. Same formulas for all the generators. PG equals to IA EG, and here PL equals power delivered this one and power generated this one. This is this one and this one is this one. Now short shunt generator. Short shunt generator. So same thing, only the difference. See the difference. So this wire is connected across this for long shunt generator. See the diagram. So this wire is connected for here for short shunt generator and for here for long shunt generator here. If this wire is connected here, that is long shunt, and if this wire is connected here, means that is short shunt. So see this here, that this wire directly connected across this one. So see this wire is connected here only. Now here see the parameters here. EG is induced EMF and V is the terminal voltage, and IL is the load current, and IA is the armature current, and RA is the armature resistance, and I series is the series field winding current, and R series is the series field winding resistance. ISH is the field shunt for current, and this is RSH is the shunt resistance. Now here two field windings and one armature winding. One field winding is connected in series with armature and other field winding is connected in parallel with armature winding. Now here what are the related formulas? Here IA and ISH formulas and induced EMF formulas we need. So here what are the same currents here? Series field winding and a load current is connected in series. So I series equals to IL. We can write I series equals to IL, and if you apply KCL at this node, and IA equals to ISH and this ISH plus I series. So see that formulas, IA equals to ISH plus IL, that means I series. IA equals to ISH plus I series. So sum of entering currents equals sum of leaving currents are ISH and I series. Here I series means IL. IL equals to I series, IA equals to ISH plus IL. Now here ISH equals to this, ISH equals to, we need this current. Now this total voltage plus I series R series and divided by RSH. This is the ISH formula. And next, induced EMF IL equals same formula, V by RL. This is RL load resistance, and EG equals to V plus IARA plus I series R series. This EG plus V plus IARA and this I series. Here this is not same. IA and I series is not same. Here you can write in place of I series IL only you can write, not same. In the previous case IA equals to I series, because this it is connected here, so this IA equals to I series. Now what are the power generated and power delivered to the load formulas? Same formulas. PG equals to IARE, IA into EG, and PL equals to IL into V. Now we will discuss. Now let us move to the applications of each generator. So separately excited DC generator, shunt generator, series generator, long shunt and short shunt generator applications. What are the applications? So first I will explain self-excited in that shunt generator. In the shunt generator, what are the applications? The shunt generator main characteristics. So here, because of constant terminal voltages are almost constant. So because of this property, here these are used in the charging batteries. So these shunt generators are used in the charging batteries, and here these shunt generators are used for ordinary lighting purpose. So shunt generators with field regulators are used in the ordinary lighting purpose and power supply purpose. And here field for giving alternator is having three. This is the armature of the alternator, and this is the field winding. So here for giving the excitation of field winding, this here we are for alternator. If you give the excitation and it acts as a magnet, and this magnet cuts this three-phase winding, and induced EMF will be developed in the alternators. So in this case, for excitation of alternator, we are using this shunt generators because of this constant terminal voltages. So shunt generators are used for ordinary lighting purpose, power supply purposes, and charging for charging batteries, and for giving excitation of alternators. This is important. And next, series generators. So here, because of rising rising voltage characteristics, these series generators are used in the boosters. So why we are using these series generators in the boosters? To compensate the voltage drop in the feeders in certain types of distribution systems, particularly railway services. In the railway services, we will use series generators, and we will also use this series arc lighting purpose. Also, we will use this series generators. And next application for of series generators. So they are used as a supplying field excitation current in DC locomotive for regenerative braking. So there are different types of braking. So plugging, regenerative braking. So now here in the regenerative braking, in case of DC locomotives, so here we are field excitation current. So for field winding excitation, we will use this series generators. Now here long shunt compound generator. So here long shunt compound generators are because of external characteristics these are used for motor driving purpose, so which requires DC supply as a constant, and for load lamps and heavy power services and electric railways, we will use these long shunt generators. And next, short shunt generators. So short shunt generators are used in it acts as a shunt generator, means for DC they are used in the arc welding. arc welding, and where large voltage drop is desirable with increase in the current. And next, separately excited DC generator. So they are used only for wide range of output voltages, for generating the wide range of voltage or output voltage. They are generally used for testing purpose in the laboratory. So the main best application is speed control of different types of speed controlling techniques. So in that, one technique is Ward Leonard system. This is a one type of speed control technique in that we will use. So separately excited DC generators operates in stable condition with any variation in the field winding. Because of this property, they are used as a supply sources of DC motors. So whose speed controls are controllable for various application. That application is Ward Leonard system. Now here, if you take one problem here, a shunt generator delivers 450 amps at 230 volts, and the resistance of shunt field and armature are 50 ohms and 0.03 respectively, and calculate the generated EMF. So now, if you what are the given data here? IL equals to 450 ohms and V equals to 230 volts, and ISH equals to 50 ohms, and RA equals to 0.03. Now calculate the induced EMF. If you draw the this is a given data solution for this, and if you draw the diagram only, then we can calculate the, no need to by heart mug up these formulas. Just if you apply KVL, KCL, if you know the series connection and parallel connection properties, then you can easily solve this problem. Don't by heart, don't mug up this that formulas, just apply KVL. Now here KVL, here IA equals to ISH plus IL, this formula if you apply KVL, and here now here this is voltage is V and this is RSH, and this voltage EG, if you apply KVL here, this is KCL, this is KVL, EG equals to V plus IARA here. Now here IA equals formula. First, to calculate this, here we know this V value 230 and RA is 0.03. Here we need the IARA. IA value. IA is calculated, IA equals to ISH plus IL. Here ISH is calculated, the supply voltage divided by this RSH, that value equals to 230 divided by this supply voltage is 230, not supply voltage, terminal voltage, and that resistance is 50, and that value is 0.046, and this IL equals to this load voltage divided by load current. This load current is 450. This 450, this is IL and this is the ISH. IL plus ISH is known as the IA. That current is 4.546. 450 plus 4.6, that is 454.6. Now already we know this IA. Substitute in this. So now thus EG equals 230 plus 450 plus 454.6 into 0.03. Now substitute, and that value is 243.6 volts. The induced EMF, the generated EMF in the armature terminals is 243.6, this value. Now second question, a long shunt compound generator delivers a load current of 50 amps at 50 volts, 500 volts as armature field and shunt resistance. Or this is the armature RA, and this is the series field R series, and this is the shunt resistance RSH, and this is IL, and this is the terminal voltage V. Calculate the generated induced EMF EG, and this is calculate this EG and armature current IA and brush drop. So brush drop also you can consider. Solution for this is the given data. RA is 0.05, R series is this one 0.03, and RSH is 250 volts. Now here load current is IL is 50 and this terminal voltage is V. Calculate the induced EMF EG and IA. Now if you draw the graph, if you draw the diagram for long shunt generator, so field winding two field windings and one armature winding. One is connected in series with the armature winding and another one is connected in parallel with the armature winding, and load is connected across these 2 points. Now here, what about EG? EG formula, EG equals to V plus IA into RA plus R series. Don't by heart this one. So this V equals to, so this EG equals to IA RA plus V plus I series R series. But here IA equals to I series. So here IA is a common term. So V plus I RA R series. So V plus IA R series, RA plus R series into IA. Same current. Now here, so here to calculate this armature current. So what is the formula here? IA equals to ISH plus this one. IA equals to ISH plus IL. So this is, you can write here I series. And here this formula. Already I wrote here. And now here ISH equals to V by RSH. This is well known formula, ISH, and this is RSH. And here terminal voltage is 500 and RSH is 250. This is 500 and this is 250 and this is 2 amps. 500 by 250 is 2 amps. And now here IA equals to 2 plus 5. This is the IL, this one. And this is the shunt current. IL plus ISH equals to armature current. This is 52 amperes. This is 52 amperes. And next, induced EMF EG equals to, this is the terminal voltage V and this is armature current IA, this one, and this is the RA and this is the R series, this one. This is RA and this is the R series. So 0.03 plus 0.05 into 52 plus 500, that equals to 506.16 volts. So now these are the problems. So if you still have any doubts in the classification of DC generator applications and problems related to this classification of DC generator, you can comment in the comment section below. I will answer to your queries. Thank you. Thank you very much to you all.
Like, share and subscribe. Hit the bell icon for more updates.